Welcome back, everybody. We're going to work on the second half of the Chapter 2 programming exercises to start out today. And you can see we have exercises 2.5, 2.11, and 2.32 to complete. None of these are particularly difficult, but the reason I choose the exercises I do is to make sure that we hit on certain key concepts so you guys know how to complete them. As I had mentioned just a little while ago, I was grading stuff earlier today, and I noticed I think only one person has turned in this homework so far, so you guys are probably all waiting for me to help to help you with it, which is fine, okay? But just please keep in mind that it's due a couple days from now, so you don't want to dawdle too much on it. Maximize your points always. All right, so the first one is exercise 2.5, and I'm going to navigate here in my ebook to that section. All right, so 2.5. Do you guys remember this one where we did 2.4? It says write a program that prompts the user for two integers and then prints sum, the difference, the product, the average, all that. And we did that in class, right? But what they want us to do in 2.5 is to take that same exercise and just simply enhance the output. In other words, use some of those little layout things that they gave us, those little shortcuts, to make it look better. That's all there is to it. So smart place to start, of course, is to open up 2.4. And maybe with any luck, that tab's still open in here. It sure is. Isn't that wonderful? Now what I'm going to do is, because this is technically a separate exercise, I am going to do a save as on it, put it in a new folder, and give it a new name. So I'm going to start by doing that. So I'm going to just do not a right click, but I'm going to go to the File menu, choose Save As, and you see I'm still in the Chapter 2 Part 1 folder, so I'm going to go up a level. I'm going to make a new folder and call it Chapter 2 Part 2. All right. And of course I'm going to call this one Exercise 2.5. I think that's good enough. Is that all right with you guys? All right, let's save it. And then if you look at what they're doing in the book here, they have this output and it's really nicely aligned. So notice like the decimal points go off to the right and everything is like right aligned, because that's like what we call numeric alignment. Like in a spreadsheet, the spreadsheet would automatically do that, right? You put a number in and the bigger it is, it goes off to the left instead of to the right, like words do. And that's so that all the columns add up, so the ones and the tens and the hundreds and the thousands are all in the same column. And it's just more comfortable numerically. It also allows you to see very quickly, which number is bigger or smaller than another. All right. Just to review with 2.4, okay, it says 2.5, but we know this is 2.4. When we ran this, and I'll just run it. Oh, that's right, we have to put numbers in. I forgot about that. How exciting. It gave us the output, but it wasn't, the prettiest of things, really. So what we have to do is use some of the tools that we saw in the book for layout. And just to kind of refresh you guys on that, there's a spot in the chapter was it here? Anybody know the page number? Do they have the book? Probably find it faster than me. And put an output. There we go. Formatted output. By the fifth time I teach this class, I'll have all the page numbers memorized, and then the addition will change. All right, so this is kind of our cheat sheet for doing this, and they give lots of little examples. Now, the way I see it, we need to figure out how many spaces we need to kind of make everything lay out. So you notice, like with this second example, we put the percent, the 5, and the D, and then it gives us 5 spaces and the numbers right aligned. So that kind of seems pretty right to me. So I'm going to look at my output here, and boy, I have to do a little bit of prediction. You know, like what's the biggest number that we're outputting? You know, it's not that big, but I can never predict what the user's going to type in, so I probably want to give it a little bit. So I'm kind of thinking with those that having at least, I don't know, 5 or 6 or 7 spaces for numbers to the left of the decimal point makes sense to me, because I don't anticipate my users are going to type in like 54,564,000,000. You know, I don't think they're going to do that. They're probably going to type in like 24 or 100 or 1,000, and that's probably about it. Of course, if they start to break my program, I would adjust, but you know, that's just my anticipation. So in order to accomplish that, there's like a little bit of syntax that we have to do. And what I'm going to do here is I'm just going to demonstrate the syntax first. So we'll do our print statement, and then inside there, we're going to put in double quotes the formatting command. So what I'm proposing so far is that we maybe do like a 6D, right? And then whenever you use that command, you would put a % here, which tells you what it is you're going to put in that format. Then you use your parentheses, and then, you know, just for example, it might just be A plus B, right? So you would do something like that. And really, actually, it would probably be more than that now that I think about it, because really, you still want the words in there too, right? Oh yeah, I forgot about that part. Yeah, so actually we'd want to put all of this inside the parentheses, but wait, it's already inside parentheses. Bingo, right? So that part we just leave alone. Now we're just going to add the formatting commands to the front of it. So I'm just going to do a little note here. Put stuff here as is. That's the tip. Okay. Now I'm going to go back to that formatting chart though, and just take a really quick look and just kind of think to myself, you know, maybe you need something a little more than that. And I don't know if you guys like see anything here that really matches our needs.
The quantity one?
The quantity one sort of, but that's got the word quantity hard-coded into it, right?
Oh, I see.
Yeah. Okay, and then what does that one give to us? Use a negative field with to left justify. So I do want the words to left justify, but we want the numbers on the right. Can I do both? So if I want to left justify my words, what I actually could do is I could do like a %, and what you pick is kind of arbitrary, frankly. But what I would do is I would actually count the characters in the longest word, and it looks like difference is the longest one, right? How many characters we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to make it 12 because I want a space after it too. So here's what I'm going to type in, folks. I'm going to type in this to accomplish that. And yeah, there are actually two statements here squeezed together. So now that I've basically figured out what I'm going to add to each statement, it's just a matter of adding parentheses and copy pasting it. So you see my strategy here? I problem solved how to do it first before I went like just trying it. Because I don't want to type that into everything right away, but I do know that whatever I put in, I want it to be consistent at the same time. So I'm going to just copy that statement, so Control C. I'm going to come into the parentheses and paste it in, and then I need to put parentheses around the original statement, like so. And you know what? Let's kind of be on the safe side and just run it as is before I go pasting everything in again. So I'm going to type in my 5 and my 123. All right, doesn't look too bad. Only the first line did it, right? You think that'll be enough? I'm guessing it'll be fine. Okay, so let's take that same approach and paste it into each one. So you see how I'm cleverly grabbing the parenthesis here as well? And I know I'm going to have to add one to the end of each line. Not a big deal. Just be really methodical. Take your time and make sure it's accurate. That one also needs an extra one at the end. A lot of parentheses at the end of that one. But see, once I figured out the maneuver, it's like paste, hit my end key or click my mouse at the end, and then add a parenthesis. I should be okay as long as I followed my pattern correctly. The one thing that you might end up doing is forgetting one of the extra parentheses, and that might break it, but it'll warn you that you're breaking it. Right? If you're not comfortable doing them all in one fell swoop, recommendation, do one at a time. Check it, do the next one. Check it, do the next one. I feel pretty confident that I got it right. So let's type in a number down here. This time I'm going to put in 13 and 24. What do you think? Not too bad, right? They're all lined up. Now those numbers kind of worked out where there were no decimal places, right? Could I force a decimal place just to see what it looks like? Sure. You just put in numbers that you know will force a decimal place. Oh, that doesn't force it either. What are we doing wrong? There is one error here I'm detecting because I pasted in all the formatting commands. When I put in a D, it's for digits, right? But now I'm not seeing the decimal place on average. Is there any other one?
0.2F.
Yeah, so I need to change the average one at the very least because that's where I might get my decimal places. And I don't just have to put an F there, I also need to put in really, you know, and I'm thinking here 6 isn't enough because now I'm adding decimal places after. How many decimal places do I want to add after? 2 is probably fine. So I'm just going to do 9.2. And now why did I switch it to 9? Because I got 2 decimal places after and the decimal point. That's 9 characters. See the difference? Mm-hmm. Just a little bit of math. If I would have screwed up and guessed the wrong numbers, or if I went 6.2, I would see it be off and then I would fix it. So let's try it now. Use the same numbers, 5, 10, and there's a 7.5 to 2 decimal places, and all the alignments are pretty. This isn't really a particularly challenging thing, but sometimes, you know, when you write programs, you want the output to look nice. One thing that I also see in here, frankly, is I don't like the fact that, you know, this is right on top of this one. Like, I would probably add like a blank line here. And you know, you can do it like this. It's a primitive way to do it, but you can do it like that. So let's try it one more time. Let's use some different numbers. I'll do 24 and 29. Looks a little better, right? A little easier to read. All right, so that's exercise 2.5. You guys cool? Any issues, anybody? All right, great. Let's move on to the next one. Yes, Athena. Okay, the question I got was, why does the print statement on line 16, why is it blank? Because when I did it before, notice that it went from the prompts, and right after the prompt, it just did the output, and these lines were together. See these? And so I thought it would look nicer if it had a blank line in between. And so I just added a print statement with empty spaces inside, and it just added a line for me. So it's kind of a primitive approach. What's another way I could have done that?
I use dashes, but that's not.
You use it, well, yeah, I suppose.
Another line is a different.
So David, you did this, right?
That, and I figured out dashes equal the.
Oh, the multiplier?
Parentheses times, and I did, 35 and print dashes. So,
Now, another way you could accomplish the same thing is you could actually put a new line statement in front of this, right? And you know what? You could just do it like, well, you could put it right inside here, And what do? Slash n? You guys remember this at all? Or did I do it the right way? Actually go backslash n. And that's a new line. So watch this. Remember, these were what we called escape sequences, and one of the most common ones to use is slash n. It puts in a new line without having to do a separate print command. Yeah. Remember, the other trick with the escape sequences was, what if you want to put a double quote inside your string, but you're opening and closing it with double quotes?
Right, single quotes.
Yeah, so then if you wanted to do that, you would just add like a backslash double quote. Not that that's a good idea here, but you can if you really want to. I mean, it's not like that big a deal, right? And then it prints the double quote where normally it wouldn't, because it would think that the statement ends here. But the escape sequence, that backslash, tells it to print a character. Because you do sometimes get these complicated situations. You're trying to print out like a quote, and then the quote has intermingled inside of it like single quotes, or you want to like quote somebody inside the quotes, you know, and it happens, you know, so they had to come up with a way to do it. I am going to remove that stuff. I think the backslash n is fine. The new line, I think, works just wonderful. So let's just leave that in there. So I'm going to call that done, folks, and we're going to move on. All right, let's figure out which exercise is next. So I'm going to go back to the exercise section of the chapter here. And it's exercise 211. So I'm scrolling down. And this is our task here. It says, write a program that asks the user to input the number of gallons in the tank, the fuel efficiency in miles per gallon, the price of gas per gallon, and then print the cost per 100 miles and how far the car can go with gas in the tank. So I'm going to do this little technique that I taught you guys, which is I'm going to just copy this text and then bring it right over to my IDE. And I'm going to go ahead and create a new file. And first thing I'm going to do is save as. This is exercise 211. I'm going to add the file extension .py. Say save. And then I'm going to add the problem description up here at the top once again, so I don't have to flip back and forth to find it. And then I'm just cleaning it up a little bit so I can read it. So this is kind of what they want us to do here. Okay, write a program that asks the user to input blah, 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 blah. So the inputs are relatively simple, right? Can you guys predetermine what type of number type I should use for these? What do you think?
Gallons would probably be, I'm guessing floats.
Okay, and I agree. Gallons should be a float, because even if you try really hard at the gas station, it's hard to get exactly on a gallon. So floating point number makes sense. What about the fuel efficiency in miles per gallon?
That would also be a float.
You think so?
I think so.
Okay. Right? And the truth is if you go looking it up, you know, for most cars, if you look it up online or something, they'll round it and they'll say 49 mpg. But if you ever calculate it yourself, it's never exact, right? It would be really rare for it to be. So I think float is once again the right answer. What about the price of gas per gallon? Also a float, right?
$7, $3 even.
Right, and even worse when you go buy fuel, it's not like, you know, 275, it's 275.9. Like they're actually calculating that. It's like, who's the criminal who thought of that one, right? Some you know, Wall Street guy or something, right? Some banker. Yeah, why not round up? And so to this day, all of our gas pumps still do that, you know. And maybe, you know, at some point in time that tenth of a penny was important, but Now it's kind of almost insulting, I think. All right, so we need to write some input statements, so let's think about doing those first. Let's just get that part out of the way, all right? So the number of gallons of gas in the tank. All right, so I'm thinking a good name for it, and I'm just putting this out here. You might call it something else. You might call it like fuel capacity. I'm calling it tank amount. That's just what I'm doing. I know that the number that we're going to get is going to be a float, and I want to get you guys in the mindset of like doing the number conversion at the same time you get the input, because normally what we would do is we would write input, right, and then say enter the amount of gas in the tank, something like this, right? We would get the input, and then in the next step we would have to like convert it to a float. My thinking always is save the step and just right in front of here type float and put the whole thing in parentheses. So I added a set of parentheses around it, and we're done. It's one statement. It grabs the input and converts the number. So that's my recommendation to you guys, is to stick with that approach. If it makes more sense for your brain to split it into two separate steps, then do that. All right. So the next thing is the miles per gallon, and MPG seems like good to me because that's how I think of it. And we're just going to basically copy this statement and just change the words, right? Why retype? So we're not going to enter the amount of gas. We are going to enter the fuel efficiency of the car. Oh, maybe we should be more specific. Maybe we should say the fuel efficiency in MPG, miles per gallon. Because enter the fuel efficiency of the car. It's good, right? Some person might type. We got to tell them what we really want. We want a number. So, what's the MPG of your vehicle? Do you guys know the MPG of your vehicle? Any of you like nerds like me? Every time I get gas, I calculate what my MPG is. Mostly because I'm proud of how good it is, frankly. Yeah, mine is actually, I average like between like 43 to 46 with my car, because it's diesel, not hybrid, diesel. All right, let's see the next one. The price of gas per gallon. So once again, I'm going to copy the whole statement. I'm going to change the variable name, obviously, to price, and then enter the cost of a gallon of gas. Okay. So I might even, if I was a good programmer, I might put a little comment in here and say, get inputs from user. I think it's kind of a no-brainer, but it's not a bad idea to put comments in. So the next thing that we need to do is, once we get all the info, we got to do all the math, right? So you might actually say, perform the calculations, or however you want to say it. Right? This is something that the user doesn't see, right? This happens behind the scenes. So now we got to do a little thinking. What calculations do we need to make? They want to see print the cost per 100 miles and how far the car can go with the gas in the tank. Interesting. How do we calculate? What's the calculations?
For the number of miles the car can go, I have you take the number of gallons, so you do tank amount times MPG.
Okay, very good, David. And that's where I would start too. So the number of miles, how far the car can go, I'm going to call it distance. And you said the tank amount, using my variable names, how much gas is in the tank times the miles per gallon, right? That makes sense. So here's what I figure out on my car, right? If I get like 46 miles to the gallon, and I have a 13-gallon tank, which is really small actually, if you think about it. 13 times 46, yeah, I get about 600 miles on a tank of diesel in my car. That's pretty crazy actually. My Toyota Highlander, completely the opposite. It's get like, I probably get like maybe 200 miles on a tank of gas. I can put a lot more stuff in it, but you know, it shows, you know, when you start calculating out the cost of the car, that's why like the author has you work those problems. Start calculating the cost of a car, you think about like how much you're paying for gas. Like I think about it a lot because I drive like 80 miles a day back and forth to get here, on average. That adds up quickly. You know, so like you get a fuel efficient car, kind of pays for itself over time. Even if it costs a little more when you buy it, it's worth it. All right, so that's how we get the distance it can travel. So what's the other thing? Print the cost per 100 miles. So I'm going to just call mine cost 100. Is that all right? Seems like a reasonable thing. So how do I calculate that?
That one I had a little bit more trouble with. I have it, I don't know if it's right.
Okay.
So basically,
What did you come up with?
basically what I did was MPG times price divided by 100.
Divided by 100.
But the way I had it written down was opposite, so it's 100 on the other side. 100 divided by,
Oh, I see what you're saying.
yeah.
Yeah, and David, that is the correct way to do it.
Okay.
So
I had to look it up.
if you want to figure out, you know, and see, the problem with an equation like this is, okay, the cost per 100 miles. The only way we can really figure that out is we have to divide the MPG into the 100 first, and then multiply by the price. That's the only way you're going to figure it out correctly. And I might suggest some of you, if you're not thinking about that, well, and remember, this isn't a math class, but frankly, folks, a lot of programming does little bits of math like this. If you're lucky, you have other people that give you the math and say, here's the math, put it in the program. But sometimes you're kind of expected to figure it out. But you know what? Keep in mind that you can always, you know, you're writing the program. If you screw it up the first time, all you have to do is change the formula to get it right. Like you might run it and some engineer at your company might say, what the heck is this? And then you go in and you fix it, right? It's not a life and death situation. You have time to repair your stuff. But this would be probably the best approach right here. All right. Now, because division and multiplication are equivalent in the order of operations, it would read left to right. It would divide MPG into 100 first and multiply by price anyways, even without the parentheses. But if you're not sure, then put the parentheses in, no big deal. Doesn't hurt anything. All right, now we need to put it back on the screen. Display results to user. Okay, and this is just a matter of some print statements, right? So this is what I had for mine. So I'm just going to copy paste them in, and you guys can take a look. And the reason I'm doing that is so I don't mistype. So for the first statement, I said, and here it takes how much fuel, and notice I have the formatting in there. So I have a $sign because it's money, right? And then I also have the 0.2F so that we can show, you know, it might take, you know, 3.5 gallons or whatever to drive 100 miles. And then I'm displaying the cost afterwards. So the percent, remember, is so that the formatting applies to cost. The car can travel the distance I calculated, miles, so like 50 miles with the gas in the tank. I'm going to go ahead and save this and let's run it. See what happens. Enter the amount of gas in the tank. Now I'm gonna go back to what I had just calculated in my calculator. I'm going to put in 13. Enter the fuel efficiency in MPG. I'm going to kind of average, like, I'm going to say like 44.5. That's probably about average for me. Enter the cost of a gallon of gas. All right, well, diesel right now, depending on where you get it from, at least for me, so this isn't gas, it's diesel, whatever. I can get diesel right now for $279.9. It seems to be a going rate. So it takes $6.29 of fuel to drive 100 miles. That's pretty good, actually, right? Cheaper than taking a bus, probably. The car can travel 578.5 miles with the gas in the tank. Now remember, I put in kind of a higher number. I put in, what, 46 before? But that seems about right. Once again, you know, I see a little bit of a formatting thing. I might put in that escape sequence at the beginning of this line again, just to print a blank line. And save it. Let's run it one more time. And now I'll do my Toyota, right? It's a 18-gallon tank. If I'm lucky, I get 20. If I'm lucky. It's probably more like 18 or 19, honestly. Let's do that. Because that's like a big V6. What's the cost of a gallon of regular gas these days, you guys? $2.59?
About that.
2.1599. So look at the difference. It costs me more than twice as much to drive that 100 miles in that car. And then I can only travel 324 miles on one tank. And you know what? That's about right for that vehicle. You know, if you're smart and you do calculations on your vehicles when you buy them, if you don't drive a lot, you probably don't think about it. But if you drive a lot, you really think about it. That's why, like, when you see a lot of people that work with their trucks, a lot of them opt to have diesels because they get those big motors and they're more efficient, even though they're still big trucks. Why do semi-trucks use diesel motors? Because they're a whole lot more efficient. All right. So that was exercise 211. Let's move on to the next one. And that was 32, correct? And that was down in the business section. And I chose this one on purpose because this one had a little pseudocode with it. And I thought that was kind of maybe like a good review. Because here's the thing. You might be in a situation like this where somebody has already figured out how to solve the problem. Or maybe it's you that figured out how to solve the problem. And I'm going to tell you what, rarely will you be doing it in your editor first. Usually it'll be like pencil or paper or calculator or a spreadsheet or a regular document or writing on a whiteboard. I mean, you don't really know, but you come up with whatever the method is for solving the problem, and that's what we have here. So the problem description says, the following pseudocode describes how a bookstore computes the price of an order from the total price and the number of books that were ordered. So read the total book price and the number of books. Okay, so that would be, for example, I don't know, $39.99, and there's 10 Python books here. Okay, compute the tax, 7.5% of the total book price. That's a pretty high sales tax. But you know, we're lucky in Wisconsin, our sales tax is pretty low. So that one homework assignment where we had to look up what the sales taxes were, it wasn't to punish you, because you can just look it up online. It's in Wikipedia or whatever. It's to give you a little bit of awareness that it does vary from state to state. Does anybody think of a state that has no sales tax? Alaska?
Really?
Yeah. And then when you move to Alaska, they give you money too. Did you know that? Did you ever see that Simpsons episode where they drive in there and they give them cash? It's kind of like not a joke. Just in case you're, wondering, In some states, Wisconsin, you don't have to pay tax on food at a grocery store. But in some states, you do. In most states, in most large metropolitan areas, this is kind of interesting, you pay more sales tax at restaurants and hotels. So in Milwaukee, it's like 5.6% if I shop for regular stuff. If I go to a hotel or a restaurant, I think it's like 10% now, or 9% or 10%. And then when you're figuring out the bill with somebody, you should know that because you have to add 20% for your tip and 10%, so you're like paying 30% more than, so that $10 sandwich is really 13 with the tip. You know, so those are kind of little things. Or you can use it to your advantage and make your friend pay the tip and the tax. There you go. That's a sneaky way to do it, right? All right, and then compute the shipping charge, so $2 per book. All right, so I got 10 books and 20 bucks. The price of the order is the sum of the total book price, the tax, and the shipping charge. Print the price of the order. That's our goal. Sounds a little complicated, but really, it's not quite so bad. Translate this pseudocode into a Python program. You know what? Sure, I'll do that. In fact, I'm going to start by just copying that text, and let's do what we've been doing and just bring it into our program. And once again, I'm just doing it so I don't have to flip screens. Could I go back and now get rid of this, like stuff that I've added in the past? Sure, if you want. If that's what makes you happy, go for it. I kind of don't care. So I'm going to put that in there. And then these are all separate sentences, so I'm separating them so I can see them that way. Just like that. Now, as we look at this, are there any values in here that you would consider constants?
The tax.
Okay, right on. Tax, I agree. The tax, I think, is a constant. So I'm going to start by doing this. I'm going to define the first constant. Why did I set it to 0.075? Because that's what a percentage is, folks, right? I wouldn't put in 7.5. A percentage can only be between 0 and 1 in value. Okay? Right. And if you don't do that, if you put in 7.5, then you got to do the multiplication or division to fix it. But it's just smarter to do this. 7.5 is actually, percent is actually 0.075. All right. What other constant do you see in the program? Yep, the $2 per book for shipping. Now I'm going to opt to put this in as a float because I am going to be working against or with prices, which could be floats, and we know the tax rate is already a float, right? So I think it makes sense to make it a float, and I'm essentially making it a float by putting 0.0 after it, even though I don't really need to, right? Because remember that process is called casting of values. Just mentioning it because it might be on your midterm. All right, so now that we have those constants in there, now we need to get information from the user, right? What's the information we need to get from the user?
The number of books.
All right, so if we're going to get the number of books, so how many books are you buying? And so this is what I did. I did number of books. I know that's going to be an integer because nobody's going to come in and buy half of a book. That half of a book is going to be in a garbage can or recycle bin. Right? And so I'm just going to say, enter the number of books. And then right away I'm converting it to an integer. Storing it in number of books. What else do I need to get from the user?
Book price.
Price of the book. And I called it book price. Just like so. So this will have decimal places most likely. And even if it doesn't, it's a good idea to put them in, very simply because it helps us to do our tax calculations more accurately. So enter the price of the book. Next thing that we're going to do is we're going to do the math. And in order to get there, ultimately what we're trying to do is compute the total price, right? All right, so here's how we'll proceed. First, we should probably figure out the sales tax. So I'm thinking, I'm just going to create one called tax equals, and how do I calculate the sales tax? How about if I take the price of the book and multiply it by the tax rate? You guys remember why tax rate and shipping per book are uppercase? Yeah. And remember, these are implied constants. You can actually change their value, but we're assuming that they can't change. All right. So I got the tax. That's great. Now what? Should I figure out the shipping?
Shipping per book times num books.
Times num books. Okay. So I got 10 books. It's $2 per book. Okay. Any other math I need to, well, I still need a total, right? So now I got to add it all together. So I'm just going to come up with a variable. You know what? I'm going to call mine total price. And, well, how do I figure that out?
Would you do the sum total of tax, shipping, and what else is there? 3 of them.
Yeah.
Problem.
Yeah. To me, there's a little bit of a couple different ways you can think about this. So I'm going to just kind of say that out loud. Because one thing that I would think about is like, if it's like how much is your book, then how many books are you buying? It could kind of be two separate things. But we're kind of combining it here, is the way I'm looking at it. Because we're saying enter the total book price. See? So the book price is going to be part of it for sure. Plus the tax. Oops. Plus shipping. Then all I have to do is put it on screen. Well, I did something wrong here. Nope, I guess not. Display results to user. And we can do that with one simple print statement. This is the one I came up with. Print the total cost of the order, and then we go into our financial formatting. And that formatting, the one that you do for dollars and cents, is one that you're going to use a lot, frankly, right? A lot of stuff that you're going to calculate is going to fall into that format, so that's going to be one that you do often. All right, let's see if this works. Oh, I didn't save it this whole time? For shame, for shame, for shame. And I'm not saying that facetiously, because you know what could happen? Because it does happen. I was in class last night, working on some code, blue screen. What if that, and it was on this computer, it could happen to me again. I don't know what caused it, honestly. I didn't look up the error code. But what if that happened to me right now and I hadn't saved all my work? Guess what I'd be doing? I'd be rewriting all this again. Right. So save often. This is exercise 232. All right, let's run it. Enter the number of books, 10. Total book price, I'd say $100. Total cost of the order is $127.50. I will give you something to think about, though. If you did it just this simply, I'm good with it. If you decided to say how many books at what price to get the total book price, I'm fine with that too. But what I always tell people is when you're doing user output, you're usually better off putting in more information than less. And this would probably be the bare minimum of what you want to put in. I would argue that for the total cost, you might actually want to do an output, and I'm not going to type it in, but just food for thought. You might want to do an output that says, you ordered 10 books Shipping is 2 times that and show the actual amount of shipping. Tax is this much. Your total is this much. Because think about like when you go to a store and you get a receipt, they detail all that stuff, right? And so your brain kind of gets used to looking at it. You know what? It's good that they do that because then you can see exactly what they're charging you for what and to see if there's any mistakes. This just gives you the total. Granted, it's right, but it might be a better plan to give the user more detail. I'm just saying. Would I accept it like this? Absolutely. Would more detail be better, like if you were doing a real professional program? Sure. I want you to think about this as well. How much different is what we're doing here than what happens in a cash register? It's not really that much different. A cash register really does this, right? We have a machine that's pre-programmed, it's got numbers on it, type in a number, press the department category. I don't know how many of you have ever been cashiers, right? I used to program them a little bit, right? Or if it's a point of sale system, you scan the barcode and the barcode reads it from a database. It's like beep, right? And you got like the barcode reads in, paper towels, $1.99, and sometimes they'll put a little T after it to show it's taxable, right? And then it just keeps adding all the stuff to the list. And every time something is clicked on, it adds it to the list. Now at grocery stores, you see it on the screen as it does it. And then when you hit, pay or print or whatever, it prints it all out and puts it on the screen for you and on a piece of paper. So this is not that, it shows you that like the programming that goes into like a cash register, for example, really isn't that complicated. And next time you walk into like, Woodman's or Pick and Save or Piggly Wiggly or wherever you shop, watch the screens and look at the simplicity of the output. They're really, I don't know what language you're using, it doesn't really matter. But the technique is basically the same. So something to think about. All right, folks, that completes our part 2 exercises for chapter 2. We are not taking a break, all right?